Alright, so now since I had kind of my general explanation, let me go ahead and show you guys what I mean by when you're getting a transmission specific tune, why you end up paying additional on top of, as I just ended up showing you, the not just dozens but hundreds of other parameters inside an ECU that you need to correctly calibrate, but also have a very thorough understanding electronically, mechanically, how all of these values and parameters end up correlating with one another, and just kind of get the overall outcome out of this. So again, I can go through here and I can explain all this stuff. It takes freaking hours just for me to explain it, just even briefly, but I'm trying to do as fast, brief, and best as I can. So back to the transmissions. Why do you end up paying for a separate transmission tune? After you do the base tune on your engine, getting things like your idle, your airflow, your RPMs, your torque output, your throttle body, your speed density tables dialed in. If you have variable valve timing, getting that dialed in as well, depending on the several different factors that end up influencing those outcomes throughout the entire engine, the performance, the response, the efficiency, the performance that you end up getting out of it. So it's very important. And then if you get into a vehicle that has supercharged, apparently these 5.7 Hemis, apparently in 2015 with the Ram 1500s, I guess you can put a supercharger on it. I guess they already have the map sensor and all that stuff equipped. I didn't realize that myself. And then you get into like these neural networks and everything, which use CAN high and low, again, to correlate several different values. This is getting into even a whole nother rabbit hole of things. But generally the airflow tables are pretty straightforward, but honestly this one has quite a bit. Then you got like your over protections for pressure, temperature, exhaust, cats, and obviously your fueling. You'll end up changing your fueling either through your injector latency or your fuel tables, or through, particularly on this one, since it has speed density, you'll end up editing it through the speed density tables, which this one doesn't have it up here. You'd have to go through these VEs and adjust it throughout here, wherever sector that you may end up needing. Same thing goes with your sparking, your ignition timing, setting that where you want to end up having it. Again, all that depends. And even as you can see here, you got part throttle, you got cold, you got where the VVT actuates, you got wide open throttle. So you have several different ignition maps at different throttle points, different temperatures, different altitudes, different manifold pressures, different intake air temperatures. The list kind of just goes on. So again, I'm trying to explain all this as fast, best as I can, just for people that are interested in seeing the overview of this. What a lot of fucking shysters and everything will do, they'll go into this driver demand table, they won't change any of the rest of the stuff. They will end up typically going into, I don't know, this one's a little bit weird. This one's going to be a bad example to show you. I'll have to show you a different torque model table, but so I guess this hypothetically, let's convert this over to foot-pounds. It's not going to end up making that at all, but at the torque converter lockup. Alright, let's just go ahead and get off this topic, otherwise we're going to get in a whole nother rabbit hole. Alright, so for the transmissions, all of these values vary per vehicle, per year, per region, per model, per submodel, per a lot of different attributes, and even when the vehicle was manufactured, on the month of the year, it can technically have a different firmware software, which could have more or less parameters within inside of it. It could have things that are fixed, it could have things that are not fixed. Perfect example, BMWs, GMs, Alphas, They pretty much everything's controlled off a module rather than a relay and a fuse. They go bad, but typically it's always a software glitch. A lot of the transmission, like the Dodge Sprinter vans, transmission issue. Typically it can be solved and protected by a electronic update through the TCM or PCM, the power control module, transmission control module. So obviously it's not a manual. So you end up going through here. You have some vehicles that do have like manual shifting. You can end up making configurations for that as well, for the lockup, the switch pressures, the RPM, the overdrive, the engagement and disengagement of the torque converter, the TCC. Again, there's the output shaft speed, the steering wheel angle. I mean, all these things affect it. The transmission oil temperature, brake pressure. I mean, it just, the whole list goes on. All right, so the point where I'm trying to end up getting to is most vehicles will end up having a eco, a sport, a tow, a 4 high, 4 low, maybe a sand, a cross country, a grass, gravel, any of these applications. So all of these are parameters, and these are actually kind of pretty basic in comparison to the potential factors of the response of the vehicle, the lockup and output of the transmission. And this can be good because if you're towing, hauling, rock crawling, have to go up a steep hill wherever you end up living, whatever the situation may be, you'll be able to optimize. Because let's not to bash on anybody, let's say you have like a Toyota RAV4 or even a 4Runner, and if you try to get up some of those hills, and let's say you stop and you have a bump or a rock or something in front of you, well, you're going to have to rev up that engine to try to get it to go, and likely by the time that happens, the open differential won't supply enough power to any of the wheels that have contact. It's going to go to the loosest or the freest wheel, and next thing that you end up knowing, the car is just spinning one wheel and you're not going anywhere, and the engine's kind of just puttering and you're rocking the car. To prevent that, obviously you tune the engine, and in addition to that, you tune the transmission that way so you can prevent those factors. The other big part to that is let's say trucks, for example. They are absolutely horrible. Here, I think I got a picture of a truck. We're going to use this picture of a truck to look at. All right, so you got your pickup truck. All right, typically first, second gear, you go nowhere. You're lucky if you make it to 10 miles an hour. The truck really just does not go anywhere. It's very common. I'm not picking on this particular truck. It happens on all of them, a majority of vehicles out there. The solution to that is you can change how long you want that gear to rev out before it shifts. So you can either make the gears very quick, where it's 1, 2, 3, 4, or you can make it where it revs out to, let's say, 20 miles an hour in first gear, and you have the applied torque to the torque converter. You have the additional power that is being supplied and output by the engine, and by the combination of these two, you have a vehicle that is efficient, that is able to literally, as it feels like, gliding down the road, versus where you're having to force or drag or again force with your foot to get the car to move this big hunk of metal down the road. Engines have a lot of efficiency, so do the transmissions. It should not feel like that. Unfortunately, manufacturers want vehicles to be like that, and they are regulated and things like this, but typically it's all out of despite and design, through several stipulations, which I'll make another video about that a whole nother time. So getting back into this, so as I said, these parameters, I mean, these are kind of minimal in comparison to what they traditionally are, but where they actually change is within the shift patterns. So these are coordinated off, again, a sector, and you have to pretty much map these out in your head where these areas are, or you can open them up and end up seeing. But typically you'll end up logging through your data log for your shift patterns and then for the output. So this one is wanting the accelerator pedal, and the RPMs obviously is here. So we'll want to be able to end up adjusting these accordingly. So again, let's say, again, first, second gear, I mean, here's 900 to 1600 RPMs, and the truck, again, is not going anywhere. The optimal power band is probably going to be somewhere about the 3500 RPMs. It really should be shifting right around this 2500 RPMs here in second gear. Honestly, this whole column needs to be shifted and moved over here to the left, in my personal opinion. And that's one way to end up doing it, or you could go through here and set this specifically for, okay, I want it 50 degrees or 50% throttle, second to third, I want it to change at exactly 3500 RPMs. Again, there's several factors, and it can take several hours, if not a whole entire day, just to end up doing this one particular set of parameters for the transmission control module. So that then you get like your baseline pressures and everything. This will actuate how much pressure is applied on the shift solenoids, on the valve body, on the clutch packs and the steels inside the transmission, the lockup of the actual clutches themselves. This will typically be like your 1, your 2, your 3, 4, and then if you have like a 5 or an overdrive, these you typically won't have to worry too much about. You obviously, it's filling, it's doing its job. This is really where it kind of ends up coming into another really important attribute, is the oncoming and the offcoming of the clutch. But as I just mentioned a moment ago, this one has normal, preference, and sport, or max, or 4 high, 4 low. So again, you have to go through and adjust all these parameters. I don't know, this one's reading this off in pressure. Engine, Newton meters, turbine of the transmission. It was wanting to read it in bar, which I don't know. I can read things better in PSI though. So what this pretty much is here is the flare up, as they refer to it, inside the torque converter. So that's pretty much the rise or the build and the lockup of the TCC for the transmission. Again, it's pretty much just starting one phase and moving throughout the rest. So by changing these, it'll change the aggressiveness, the response, as I was mentioning about like on the hill or going from a stoplight, whatever the occasion may be for your overall necessity or need. Same thing with the downshift. This is real kind of important too. You can either make this real good or real bad. Typically, I mean, it's always a better thing when you do end up tuning these, but this is shifting down from second to first. You have to be able to kind of decipher where these parameters sit. You'd have to go through your data log and see where these values are with inside your RPM and other correlations. But again, normal driving, you're driving your truck to work. Typically, you want it to have that performance. You want it to be able to shift efficiently and be fuel economy. All that stuff's good. That's where we end up setting this normal at. Then the performance mode or sport mode or whatever they want to call it, this is where we see what we can kind of unleash out of the vehicle, keeping the engine load below 3 grams per revolution. And the reason why I end up mentioning that, that's about the amount of strain or pressure or force that the engine is being exerted, and typically anything above 3 grams per revolution per minute is considered static compression ratio. Anything above 18 or 19 to 1 compression ratio, you're pretty much going to detonate the engine. You're in red territory. So, for demonstration purposes, we're going to say the sport is the towing, because most of these vehicles do have a towing feature. Same exact thing. We want to try to build that low end torque, but we want to do it safely. We don't want to exert too much on the actual components of the drivetrain, because then you may break things, especially if you have something heavy, or if you smash your foot in it a little bit too fast, things like that. But again, being able to efficiently set it up so you can tow these things with ease, and then again, as you know, with engine braking, be able to have the engine downshift when you need, that way so you can come to a safer stop and put less wear and tear on your brakes and other parts of your system. So that's why it becomes so important to tune the transmission, especially if it has selective values and you're using the vehicle for different applications. If you're just daily driving the vehicle, and if you have absolutely no fulfillment, which I still personally, even if you were to sell this car in the future, I would go ahead and do it all and do it correctly so you have the whole package. That way so somebody else can get in and go. But regardless, even if you just wanted to tune the normal parameters and maybe do a slight modification to the rest, you can do that, or just tune the normal parameters for the daily driving occurrences. But just do keep in mind, it's like cleaning half of a table. The other half of it is still dirty. So when you go to use these other modes, you're going to shift into them and be like, what in the hell happened to my car? It drives like complete dog shit. Heck, it drives like when I bought it, is how it's going to feel. And if you shift back into the other modes after we've revised it, you're going to be like, wow, there we go. My car's back. It's live. All right. Well, without ranting on too much longer, because I guess I've already been on here almost going on 20 minutes. You can also change, again, the shift timing. Upshift, oncoming inertia mode, delay, normal slip time, ramp time. So as I was mentioning a moment ago about the ramp time, the flare up, fill time, off-coming inertia mode. So again, a lot of this stuff is just controlled off pressure and temperatures and friction and all that stuff. But I just wanted to show you this to give you an idea of what goes into this. I mean, this isn't something simple, and you have dozens, if not hundreds of these. And honestly, I mean, it's enjoyable when you're tuning the car and you can feel the improvements, but it's kind of a freaking headache beyond that, though, to be honest with you. And again, I mean, you got to be able to understand this stuff. I mean, most people, you get in here, start poking around, well, you're going to have a car that is undrivable. Well, you got your ramp rates and everything. Alright, so that just kind of shows you. So now, if you can remember anything without having a shell shock, say like a 15 Sierra here. You can already tell right off the bat, a lot of parameters completely different. Nothing is the same, not the system, not the function, not the dynamic, not really even the terminology or the phrases or the values that are used. So I mean, again, each vehicle is unique, and I mean, I don't know, you don't have to be a one and only tuner of one particular application. I tune everything from Hondas to Lamborghinis to semis to school buses to boats to motorcycles to, I mean, really just whatever pretty much has an engine or something with combustion in it. And it's really just, it can be a learning curve within some of these, I'm not going to lie. And there's no tuner out there that knows absolutely all this. We're constantly learning, there's constantly new technology. It's not really technology, it's just a general standalone engine is kind of very basic for the most part. And here we go, I'm getting off track again and everything. It's like these Holly Terminators, I don't know, I think they're all right. I mean, I'm not really too crazy and hoot and holler and everything about them, but I don't know, do fucking damn LS, as everyone likes them. So I mean, you have a standalone ECU here. You have your fueling map, you have your sensors, you have pretty much your system of how everything's going to be configured, how everything's going to correspond. It's still, again, pretty basic overall. You got your spark tables, your transmission if you're utilizing a automatic, your drive-by-wire. So pretty much you're controlling your throttle, you're controlling your ignition, you're controlling your fueling. And as long as you can have your manifold absolute pressure sensor, you can have your crank and cam sensors, your cam for your engine phases and injector angle, as you can see down here. Same thing with uh, the crank angle for the ignition timing. So I mean, you have a lot less parameters and everything inside of here in versus of comparison to a factory ECU. So I mean, again, there's a lot to it, and realistically, there's no one out here that can tune a car within an hour. Yes, even if you know exactly which parameters to go after, exactly which one to set. Every single car is different. Every single batch of fuel is different. Every single region of fuel is different. The ethanol content, the barometric pressure of the altitude is different. The weather is different. The humidity is different. The wear on the seals on the intake manifold or other parts of the car is different. The wastegate may have dirt or dust that's causing it to get stuck within the diaphragm. I mean, there's so many factors. There's not one shoe fits all. The engine can have wear in it. It can be having engine oil consumption. It can have low compression. The freaking list goes on. So that's why flash tuning is really unviable, and then even e-tuning really is a entry level. If you're mainly a base map is where I consider those at, your flash tunes and your e-tunes, because all you're doing is pretty much getting the vehicle operable. But with that being said, I guarantee you're going to have a lot of knock and or just general roughness out of the engine, and you'll have poor inefficiency. You won't be reaching as much power. Again, efficiency is power, and that's really a big misconception that a lot of people kind of fall wayside to. So, and I mean, here's for like the F-150. It's one that's torque reduction is not too bad. You have your shift properties here. And this one, since it has a turbo on it, it applies boost pressure, manifold absolute pressure to it. So I mean, again, just the values and everything are very different all the way throughout. So I'm not going to rant on too much more. Hopefully this was informal, and hopefully you ended up learning something, and this was able to give you some insight or answer some questions. Um, if you guys have any questions or obviously need service, feel free to let me know, and I can get you all situated. So I obviously have passion for what I do. I've been doing it for over 20 years, and just it's like everything. Just want to see things done right. Want to see people live good and people treated fair. So that's all I'm trying to do here at the end of the day. But all right, so that's gonna wrap it up here for I guess kind of the transmission stuff. Um, I guess I could go into a whole another. So you even have like the fault code for the TCM and everything that can end up affecting it. I don't know. We've gone over enough of it, and the VSS and all this stuff. So all right.